let's just jump right into this explainer and tackle one of the absolute most frustrating network problems you'll ever face as a developer. You've built a killer app, but suddenly things aren't working, and your standard dev tools are just giving you nothing. Today, we're doing a deep dive into the Charles Proxy 4x free trial to see how it lets you intercept, inspect, and debug literally any mobile or web request like a pro. Imagine this exact scenario. A user is in your mobile app, they tap Submit Payment, and nothing happens. Seriously, zero UI error, the app doesn't crash, and you're just flying completely blind. You're sitting there asking yourself, why on earth did the mobile payment fail silently? Without visibility into that network layer, you're honestly just guessing. And the culprit here is modern HTTPS encryption. You can't just assume what the app is actually sending to the backend. Without a proxy in the middle, your app's secure network traffic is basically a totally unreadable black box. The data is securely encrypted from the device directly to the server, which means your standard front-end debugging setups simply can't see the exact JSON payload or the headers being sent over the wire. Section 1. Unmasking traffic with Charles Proxy. Charles pulls this off using a really clever technique called SSL proxying. It essentially acts as a trusted man in the middle. What it does is dynamically generate a certificate for the server, decrypts the HTTPS traffic so you can actually read it, and then re-encrypts it before sending it on its way. It's basically acting as a trusted certificate authority right there on your local machine, safely unlocking that encrypted black box. Moving on to Section 2, routing devices and trusting certs. The magic number you want to remember here is 8888. That's the default port Charles uses. To connect your mobile device, just make sure your phone and your computer are on the exact same Wi-Fi network. Then grab your computer's local IP address and pop that, along with port 8888, straight into your mobile device's manual Wi-Fi proxy settings. Okay, so here's the exact workflow. First, set that manual proxy. Second, open your device's browser and head over to chlspro/SSL. Third, install the certificate it downloads. And listen, step 4 is absolutely vital. If you're on iOS, you have to manually go into your settings to enable full trust for the Charles root certificate. For Android N and above, you need to add a network security config file to your app. If you skip this step, your device is just going to flat out reject the connection. I know it sounds like a few hoops to jump through, but a Cleverroad case study really hit the nail on the head, stating, without this capability, it is very difficult and time-consuming to determine on which side an error has occurred. This setup is exactly the bridge we need between a front-end button tap and a back-end server log. It finally ends the classic finger-pointing between the mobile and back-end teams. All right, Section 3, inspecting live API requests. So we hit that Submit Payment button again, or you could send a test request to a sandbox REST API like httpbin.org, and you literally watch Charles break down the transaction into highly readable parts. You just use your cursor to expand the request details and isolate exactly what our apps send over the wire. We're talking the target endpoint, the request headers to make sure your auth tokens are actually there, the exact JSON payload, and of course those crucial response status codes coming back. And boom, just like that, we found the bug. Looking right at the JSON payload, we can clearly see our mobile app sent a malformed request body. But here's the real kicker. The backend swallowed that bad request and returned a 200 OK success status instead of throwing a proper error code. So the app saw that 200 OK, thought everything was totally peachy, and just sat there. That's exactly what caused our silent failure. Section 4. Faking errors with Charles rewrites. Now that we've spotted the problem, we need to test if the mobile app can actually handle a proper backend error gracefully. And we want to do this without waiting for the backend team to write any new code, right? Well, Charles has this incredible rewrite tool for exactly this scenario. Here's the setup. You go to Tools, then Rewrite. Add your specific API endpoint under Location. Then throw in a response status action. Pay really close attention here, because Charles requires the regex format matching the status code and the message together. So in the match field, you're going to put 200.**, and in the replace field, type in 400 bad request. We trigger the payment one more time, and this brilliantly illustrates the real power of Charles. Before, we had our original 200 OK response causing that incredibly frustrating silent failure. But now, by forcing the 400 error in real time using our rewrite rule, we instantly see the app correctly catch the error and display a payment failed dialog to the user. We just validated our front-end error handling dynamically on the fly. And the crazy thing is, the rewrite tool is ridiculously versatile. You aren't just limited to swapping status codes around. You can modify the entire response body, inject missing CORS headers to bypass strict browser restrictions, change query parameters, and even export all these rules to share with your QA team so everyone is simulating the exact same edge cases. It's a real game changer. Now, if you want to take things a step further, Charles offers a feature called Map Local. Imagine your backend endpoint isn't even built yet, or maybe the server is currently down. You can use Map Local to intercept the request and feed your app a mocked JSON file saved right on your own hard drive. It replaces the live backend response entirely, which keeps your front-end development moving without skipping a single beat. From unmasking encrypted traffic to rewriting server responses on the fly, Charles Proxy is absolutely essential. You've gone from flying blind with those silent failures to manipulating secure network traffic like an absolute pro. So, looking at your current backlog of tickets, what elusive API edge case are you going to conquer today? Thanks for joining me on this explainer, and happy debugging!